All right, so let's try this practice problem right here. I have it balanced. How many grams of HF can be made if you have 55 grams of fluorine gas to start with? There's something in this problem that tons of you do wrong. I'm not going to tell you what it is. If you're like kind of not still with me, you're like, I don't remember how to do this. This is the one with 3 vertical lines. I know those aren't straight, but I don't really care. Oh, that equal sign is subpar. All right. If you're just stuck, just wait. We're going to do grams to grams a ton today. You'll be very bored of it. If it's clicked, it'll be real boring. I'm sorry. All right. I am going to work through this. With some good counseling, we can all make it. So now, I did not expect this to go perfect because it was the last thing we did yesterday right at the end. But by the end of today, I expect this to go perfect. Those are my expectations, they're not too high. So hopefully everybody knew what to start with, and that was 55 grams of fluorine gas. Now, when I said usually tons of people do the same wrong thing, it's right here. Fluorine is diatomic, right? That's going to matter when we find this. But let's just together for a minute, let's remember that whatever unit is here goes here. Whatever unit is here, those look like the same colors. That goes there. That's bizarre. And that one doesn't show up. Whatever unit is here goes here. And then let's just go with this beautiful thing right here. Whatever unit is here goes there. You with me? Okay. So we know the setup. So down here must be grams of F2. Now I'll come back and do all the numbers in a minute, but let's set up the scaffolding here. Grams, we said a ton of times yesterday, and today we got to memorize it. Grams is always per 1 mole of the same substance, right? So 1 mole of F2. And if that's moles of F2, then I know it matches down here, right? So down here in this, which was supposed to be green, which is now yellow, is mole F2. Okay, if we know where we start, we keep going till we get stuck, and then we go backwards, right? So I go to the end. I want to solve for grams of HF. And then we know the unit at the end is the unit at the end. We all right with that? And tell your partner, a gram of something is always over what? 1 mole of what? The same substance. So this denominator is 1 mole of HF. And then if I know this, then I know that has to be mole HF. And now I'm ready to plug all the numbers in. And usually, even if you're like a genius and you got it this far, that's awesome. This is where you get wrong, because fluorine, you look at the periodic table and it's 19, right? You have the F and the 10, or sorry, the 9. But this is F2, which would mean this is times 2, which means this is 38. Okay, don't forget the diatomics. You have to double their mass. If you don't, you'll be half or double what the answer should be. Okay, back to the mole and mole. That just comes from here. So in front of HF was a 2 right here. In front of F2 was a 1. And then my grams of HF, it's 1H, which is 1, plus 1F, which was 19. So this is a 20. And then I'm ready to do math. I take 55 times 2 times 20 and divide it by 38. What'd you get, Lilia? Okay, did anyone else have 57.89? Okay, so doable, hopefully. Okay, let's do some practice. And I know the ones that this clicked early are bored. but I have to repeat. This takes a lot of repetition for it to really help and click. Okay, this one's already balanced. If you ever have a decomposition of a family 2 carbonate, this is on page 15. It's already going to be balanced, just the way it works out. Yes, ma'am. I would love to. Okay, this is a great question because a lot of kids in other hours are really struggling right here. That's good, Zito. She said, why don't I double the 20, right? Because of this 2, correct? You don't do that because you did that here. If you double it here also, then you've done it twice. Now you could, I would not, but if you doubled that, then that has to be a 2. And you can do that and the math will work fine. I would not do it because it's just another place you might mess up in the long run. But anytime I find grams from the periodic table, I say it's 1 mole because I know I'm going to take care of the coefficient in a different step. Great question. Okay, here we go. So we have number 43 on, is it page 15? Was I right? Okay, give that a shot. Magnesium carbonate decomposes to form magnesium and whatever. Like, these are great, but they don't help you answer the question, right? The second sentence is what you need. How many grams of magnesium oxide from 20 grams of magnesium carbonate? Okay, see if you can go from there. If you're already done, you're amazing. I think it is right. It's good. Okay. So first thing first, I know that these are going to match. That's 2. These will match. These will match. And these will match. So the first thing I need down here is grams of, and I'm going to do the letter trick just for fun. I'm going to call this A, B, and C. So MgCO3 is A. So I'm going to have grams of A, and grams are always per 1 mole of the same thing. 1 mole, and I'm going to call it A, and A just is representing MgCO3. So I just didn't have to write it as much. That means that down here, I must have the same unit, mole of A, and it's going to be nice. There's just 1s everywhere, right? All right. Now, that's where I get stuck. MgO, I'm going to call B. So over here, I have grams of B. Grams is always tied to 1 mole of the same substance, which is B. And these units match right here. So this would be mole of B. And then I'm ready to plug in numbers. Grelis, am I losing you somewhere? You good? Okay. So now, number-wise, MgCO3, is that 80 something? 84? What is this one? 84. Okay. The moles in front of B and A are both 1. That makes math real nice. And then B is MgO, which is 40. Correct? Okay. So I take 20 times 40 and divide it by 84. 9.5. Okay. Okay. Whatever. Yes. How did we get 40? All right. Let's talk about that. B is Mg and O. So I go to my periodic table and find Mg, and it's 24. Far left. And then oxygen was 16. So I add 1 and 1 of them, and that's where I get 40. Okay, 9.5, raise your hands if you got that. Okay, next, number 44. I have this for you. It's a 2-3 swap, so a 2, a 3, and a 2. And then try that on your own for a few minutes. All right. So was this one a big number? I can't remember. If it's a big number, it doesn't matter. It might be small. I don't know. Here we go. I should know that those will match. These will match. Those will match. And these units will match. So hey, just for fun, I'll just start at the back. If I'm solving for grams of gold, I'm going to put grams of AU. And then tell your partner, every time you write grams, it's going to be tied to what? 1 mole of the same thing. A lot of you are starting to get a little lazy and like, so let's pretend you just had like 1 M. Well, that's great, but well, then what goes up here? We don't know. We need to be more specific. We have moles of AU right here. And then I don't know what goes there, so I better go back to the start. If these are grams of gold 3 chloride, then this better be grams of gold 3 chloride. And grams, we just said, is always per 1 mole of the exact same substance, which means this must be mole AuCl3. And then we're doing all right. Okay, time to go find things. In front of Au is just a 2. In front of AuCl3 is a 2 as well, right? So math-wise, that will cancel out. Is this 303.5? What'd you get, Shelby? 232. If you got 232, then you forgot to multiply chlorine by 3, is my guess. All right, then AU, is that 197? Man, I hate being so smart. It's like, it's rough. Some of you can relate. Did you just blink at me, Shelby? I did not appreciate that. Okay, then math-wise, don't put these 2's in your calculator. The same number on top and bottom cancel out. So, I mean, you can, but why risk typing something wrong when you don't have to type it at all? It's like those kids that put the park brake on, parallel parking. What are you doing? Because you're going to lose points when you forget to take it off and you need it on in the first place. Kids, give me a break. Oh, sorry, I was a little too triggered there. So 60 times 197 divided by 303 equals some number. What? 38.9. Can I get an amen? Amen. All right, Grace, how's it going? Okay, anyone else absent yesterday? How's it going? Yesterday's class video is uploaded, recorded, and it's one of my greatest hits already. It had 5 views out of this morning. Yeah, I'm pretty legit. I have 102 subscribers now. My merch store stuff's flying out of. So, okay, it's not, but I should make some TD merch. TD Kim. Yeah, Tom Davidson. Oh man, now we're talking. Is there like a way to make a ton of money? Eventually. Hey, is this, yeah, this is 45. Last one in the practice. There's some big numbers here. You can do it. You want me to bounce it or you want to give it a good old fashioned try real quick? Why don't you try and balance it on your own? I see lots of 3s and 2s. This equation just floats my chemistry boat. Okay, I will do this problem like a minute behind you. So if you get stuck, you can look up. If you don't want it spoiled, then don't look up. Yeah, I tried to make it like super hard to see though. So if kids just glanced up there, they wouldn't know. It was kind of like last night. The YouTube was like 1 solid minute behind the actual game. So Nelson kept texting updates. I'm like, I want to watch this game. So like, yeah, it pops down at the top. Finally, I'm like, I'm just gonna go mute this conversation. But for a while, I'm like, get out, I can't look. What's the molar mass of these things? $67. 133. All right. I have been forbidden to speak by Shelby. Shelby scares me. So. You guys match? Yes. Sweet. All right. So let's just check the work. I never did the answer. I wrote it real light, so it'll be hard to see, but we'll get it right here. So here we go. Hopefully I did it right. We had 30 grams of my given. Now, I didn't feel like writing AlBr3 and AlCl3 a ton, so I just made them A and C. Are you comfortable with that? Okay, so 30 grams of A, then that meant grams of A had to come down. Grams is always tied to 1 mole of the same substance. So that's why mole is on top. It's a 1 because this is from the molar mass on the periodic table. All right, if this was moles of A, then moles of A had to come down here. And then it was a 2 because of the 2 in front of what you are representing with A. All right, and then you would have got sort of stuck. So you had C grams, so you knew you had to have grams of C here. Grams is always per 1 mole of the same substance, so C and C. Then up here, moles of C. This is a 2 because there was a 2 in front of C as well. Then I just plugged in, actually I just copied from Luke. That was 267 and 133.5. Oh, and this is the one that is hard to believe. It's as easy as it is. What's the answer? 15. So all that math just to divide 30 in half. That's a poem. I am a literary genius, and I wasn't even aware. Never mind. I was trying to say I'm a poet and didn't know it, but in a different, smarter way. Okay, I'm just gonna shut up. Okay, 15. Thumbs up if you had 15. All right, all right, all right. Looking good. Bukers? Good. Sorry, that not being rude. She was gone. All right, back row. Good. Wells? Okay. Did everyone have it right? I never saw a thumb, Tiny. Okay. Everyone had this right? I've never been a greater teacher in my life. Okay, like for real. I don't know. I've never done a better job. All right. The next 10 minutes, I would like you to take a Canvas quiz. So grab an iPad. You're going to go to Canvas. You can do it on your phone if you feel like it. And it's like gram to gram practice. You can move that. There you go. All right, if you're on Zoom, which no one is, if you're watching this video, go to Canvas, take this same quiz and see how you do. All right, so our average was 83 for our class. Hopefully things went well if you didn't do well. Okay, that'll wrap it up for today.